And our topic for today is capacity. You are familiar with capacity from primary 2. Capacity. But today we are going to be studying capacity in another dimension. What would you be gaining by the end of this lesson? By the end of this lesson, you should be able to find relationship between liters and cubic centimeters. You should be able to identify the use of liter as a unit of capacity and the established relationship between liters and centimeter cube. That is, today you are going to know the relationship between capacity and volume. Do you still remember what capacity is from primary 2? Capacity is the maximum amount of something, especially a liquid, any container can hold. This is what capacity means. The maximum, that is the highest quantity of liquid any container can hold. You can see other containers, nothing here. A quarter full, half full. This is half full, this is empty, this is full. So the ones that are full explain capacity better. Capacity is the highest amount of liquid any container can hold. Now let's look at the relationship between liters and cubic centimeters. The unit for capacity is in liters, which is written as L, while the unit for volume is in cubic centimeters, which is written as centimeter cube. Centimeter raised to power 3 is called centimeter cube, also known as cubic centimeters. You can see how I've equated 1 liter to 1000 centimeter cube. Okay, this centimeter cube represents volume, the liter represents capacity. Now, if you get an answer in volume, which is in centimeter cube, and you have to take it to liters, just simply divide that number by 1000, okay? And if you are to convert from liters, maybe you are being given a value in liters and you are to change to volume, just simply multiply by 1000. You are going to see examples like this in subsequent slides. Now you can see, look at this jug, 1000 centimeter cube is equals to 1 liter, just like we wrote here. All right. Now 1 centimeter cube, they are converting from volume to liters. It was divided by 1000 because 1 divided by 1000 gives you 0.001 liters. Now, we're still looking at the relationship between liters and cubic centimeters. Capacity of container and its equivalent volume of cube. Look at this container, okay? Oh, this is a cube, sorry. This is a cube. Look at the dimensions, 10 centimeters, 10 centimeters, 10 centimeters. It's only in a cube that you have all the dimensions equal. Do you still remember the difference between cubes and cuboids? While for cubes is length times length times length, for cuboids it will be length times breadth times height. So when you have your dimensions equal, that's the characteristic of a cube. Now a 10 centimeters by 10 centimeters by 10 centimeters cube would give you 1000 centimeter cube. I multiplied these 3. It gave me 1000 centimeter cube. Now, do you know that this 1000 centimeter cube, just like I explained in the last slide, is equivalent to 1 liter. 1 liter is equal to 1000 centimeter cube. So that's why for this bottle that is 1 liter is going to fill this particular cube. Okay? 1000 centimeter cube is equivalent to 1 liter. We are still dealing with relationship between liters and cubic centimeters. Now we are going into some examples. What is the volume of a cuboid in liters if the sides are 15 centimeters, 10 centimeters, and 20 centimeters? When you find the volume, then you change it to liters, which is capacity. Remember, our volume is length times breadth times height. So length 15 centimeters times breadth 10 centimeters times 20 height 20 centimeters, which is the height. 15 times 10, 150. 150 times 20, that's 3000 centimeter cube. After getting your answer in volume, then you will change it to capacity, which is liters. Do you know that in liters, do you remember that in liters, 1000 centimeter cube is 1 liter? So how much will be 3000 centimeter cube? Just divide 3000 by 1000. All these zeros up, the 3 zeros up will cut the 3 zeros down. I'll be left with 3. So the answer is 3 liters. So anytime you are being told to find the volume of a cuboid in liters, you first of all multiply the 3 dimensions to get answer in centimeter cube. After getting the answer in centimeter cube, you go ahead and divide by 1000. That's going to get you your answer in liters. Now look at the second example. How many 100 centimeter cube bottles are needed to hold 9 liters of liquid? Remember, 1 liter is 1000 centimeter cube. So we first of all converted 9 liters to centimeter cube. Okay, in this situation, we are trying to change our liters to volume. How many 100 centimeter cube bottles are needed to hold 9 liters of liquid? You can see that the numbers are underlined. 100 centimeter cube, 9 liters. So first of all, change your 9 liters to centimeter cube. How? 1 liter is 1000 centimeter cube. Remember, I told you when you want to change your liters back to volume, you multiply by 1000. That's why you have 9 times 1000, which gives us 9000. So 9 liters is 9000 centimeter cube. When you multiply your 9 liters by 1000, you are going to get your answer in centimeter cube. So how many 100 centimeter cube bottles are needed to hold 9000 centimeter cube? Remember, I've changed my 9 liters to 9000 centimeter cube. So just divide this 9000 centimeter cube by 100. That is what you have here. The 2 zeros down will cut 2 zeros up. So you are left with 90. So it means 90 100 centimeter cube bottles will be needed to hold 9 liters, which is 9000 centimeter cubes of liquid. You can listen to this explanation again for better understanding. We are still looking at the relationship between liters and cubic centimeters. Example, what is the volume of a cuboid in liters if the sides are 15 centimeters, 10 centimeters, and 20 centimeters? I've explained that earlier. I think it's a repetition. Okay, so you can also look at it again. Volume, first of all, multiply your 3 dimensions, length times breadth times height. Then you take it to liters. Since the question is asking volume of cuboid in liters, you divide by 1000. The answer you get in centimeter cube, you divide by 1000 to get the liters. Now let's look at this exercise together. What is the volume of a cube with sides 5 meters? Now remember, we were given only one side, but they want you to think that since it's a cube, it has all its sides equal. So if the length is 5 meters, the breadth will be 5 meters, the height will also be 5 meters. You have to leave your answer in liters. Then you have to change the side to centimeters before working. Remember, we were given the dimension in meters, so you have to change to centimeters before working, because for you to calculate volume, the unit is centimeter cube. So if you are being given your value or unit in meters, first of all take it to centimeters. So our solution, first change 5 meters to centimeters. How? Remember, 1 meters make 100 centimeters. So 5 meters will be 5 times 100 centimeters. So it means the side of the cube is 500 centimeters. Since it is a cube, all its sides are equal. So the length is 500 centimeters, the breadth is 500 centimeters, and the height is 500 centimeters. Just multiply the 500 centimeters in 3 places, and our answer will give us 125 million. Or you can say 5 times 5, 25 times 5, 125. Then you add all the zeros here. 1, 2, 3, 4, 5, 6, 6 zeros. Okay, that's how to multiply numbers that end with zeros. Pick the non-zero numbers and multiply them by one another. Then you add all the zeros you have in the question. So when I multiplied my 500 centimeters by 500 centimeters by 500 centimeters, the answer was 125 million centimeter cube. Remember, we have to leave our answer in liters. So change this to liters. How? So in liters, remember 1000 centimeter cube is 1 liter. So 125 million centimeter cube is going to be 125 million divided by 1000. Do you know that I have 3 zeros here? So you use 3 zeros here to cross out the 3 zeros here. You are left with 125,000. So the answer is 125,000 liters. You can also listen to this explanation again for better understanding. We have come to the end of today's lesson. I hope you enjoyed the class. Thank you for watching. Bye.